Hi, welcome to physics. This is the force on a spring extension. We've done this a million times, but now we're going to do it again. We've got a spring set up here, we've got the ruler set up here, we've got some errors that I've already established where I've got the ruler is not in line with the spring. The first thing I'm going to do is I'm going to move the ruler down. I'm going to move it down to the bottom of the spring because all I want to measure is extension. Okay, so now what happens is, I'm just going to take different weights, I'm going to put them onto the spring and I'm going to show extension. So first of all, I've got a force that I'm going to apply. This one is, let's pretend it's 1 Newton. And so when I put my 1 Newton on there, I'm going to see an extension and I will measure the extension. Then, take my second weight and I put that on there and I'm going to see a second extension. I keep recording all of these. Next mass that I'm going to put on. Third extension, I'm recording these all the time. As you can see, the extension is getting greater and greater, and we should see a linear relationship between the two. So as I increase the masses, then I'm going to get a greater extension. And so let me refer to the graph here. So if you have a look at the graph, we'll see that what we should get is this relationship going up here, and we'll get a limit of proportionality where if I add any more weights, then what will happen is that it will not return to its original shape. The equation that goes along with this, if we're doing a triangle, it's F equals KE, so I'll put the F at the top, equals KE, where K is the spring constant and E is the extension. Sometimes they're going to ask you to find out the spring constant, in which case you're just going to rearrange that equation. The other equation that you'd need to know, you don't need to know because it's given to you, is the energy stored in the spring, which is also the area under the graph. Would be energy equals half K E squared, which is similar to the kinetic energy equation, but this time we're using the K being the spring constant and E is extension. So K equals spring constant and E equals extension. Things that they might want you to know about would be errors that come along with this. So if you don't measure the actual extension and you're actually measuring it from the beginning of the spring, you won't get that graph going through to zero. And obviously if you've got zero mass on there, then you're going to have a zero extension. And that's what you need to be aware of. Okay, that's the force on the spring.